Good morning, everyone, and welcome back finally to another day of Life of Pri. Sorry to keep you all waiting, but I can't do this every single day. So just when the mood hits me, right? Anyway, today has been a busy morning. I finished doing some preliminary grading on lab reports for the class I am the TA for. Then had to answer a lot of emails looking for housing for Fargo, so that's exciting. I'll probably end up going for 5 weeks, still figuring out the exact dates with my professor and stuff. And now I'm about to head out to the student farm to help out there. I got my coffee, and from there we'll probably go to the field just to check it out. It's been a little bit, and then go into lab. So yeah, stay tuned. So today at the student farm, I helped once again with seed saving for the jalapeno peppers and the bell peppers. Each week they collect peppers until the plants mature and die. Okay, we are almost done with the pepper seed saving for today, but I had to leave a little early because I suddenly remembered that we have our weekly lab meeting today, and I don't want to miss that. So heading to that next, and then field/lab work. We'll see what happens. So it turns out our next stop is the greenhouse, actually, after our lab meeting, and today I'm collecting leaf tissues for DNA extractions. It's really quite simple. You just take a snippet of a leaf and put it in the plate, but I'll show you anyway. So here's plant number 1, and I want a leaf that is still green on the younger side, and this is a good example. So there we go, and just plop it in, and well, okay, it's a little too big, so I'm going to take off the end, and now put it back in. And there we go, we have our first leaf tissue sample in the well, and on my handy dandy notebook, I'm able to tell exactly which plant that was. It was B7 number 1. I am now in the lab after finishing the tissue collection, and it's time to analyze the 6 plates that my undergrad assistant ran for me. And today I want to show you how I analyzed the data off of the KlusterCaller and Omega machine and in Excel instead. So on the left here we have the raw data, which is in a 384 well format. And I want to split it into the 4 quadrants. So 4 96 well plates, and the format for that is here on the right. So to do that, each quadrant well corresponds to a master plate well. So quadrant A1, well A1 corresponds to well A01 on the 384 plate. And so using VLOOKUP, I can look up A01 in the master well and find its call. The call corresponds to whether it is a B, A, or het. I then apply this function to every single well in my 96 well plate format. Now I know earlier I said that the blues and reds, right, represent A's and B's, but that was only for an example. I'm now going to use actual real life genotype data. And so XY or YX represents hets, but the XX, which was blue, represents the genotype Burkitt, while the YY represents the genotype called PBW. And I need to transform this column now from X and Y's into either B, a P, or H's. Once everything has been transformed, it's time to color code it to make it more visually pleasing. All P's will become red, B's will be yellow, and I like to make the heads green. It is now beautiful, and I take this reorganized data to the data file for the actual plant numbers, input it, and we'll eventually run more markers. The end goal is to run several markers for every plant, so you get something more like this, and you can actually see the chromosome in a way. Each marker represents a spot on the chromosome. Okay, so it is now 6:30 and I'm just leaving the lab after analyzing those plates. I don't think I'll be making it out to the field today because I have an errand where I need to go make more copies at the Newman Center. And also I'm starting to get hungry. So I think we'll just leave the field work for tomorrow morning. Anyway, I hope you all had a wonderful, what is today? Wednesday. A wonderful Wednesday. And I'll see you in the field tomorrow.